Alright, in this video we look at another accumulation function example. And so just want to point out here that there are going to be a couple functions involved. There is the function itself, and then there is something called the accumulation function. And the accumulation function is accumulating through an integral, a definite integral. It's accumulating area, both positive and negative area, signed area, from some number a up to x of the given function that we had. Okay, so in this example we're going to look at the function itself being the sine function. Okay, and we're going to choose a is equal to 0. And so we are going to find an accumulation function for 0 up to some number x of the function sine of x dx. Okay? Now first things first, let's try to get an idea of what is happening in this problem. There is a dotted line function. That is the function sine of x. You can see that it has that shape of the sine function. And what we are accumulating in this problem is accumulating area. So as the number x increases, x is the variable, so here is x is equal to 1.1, x is equal to 1.8, x is equal to 2.6. You can see that we are accumulating area, and as x gets bigger and bigger, that is why on the accumulation function, which is the solid line, the red dot keeps going up and up and up. But something interesting happens right here at this point. This is the largest area that we have accumulated. You can see that it is at the biggest value. It looks like it's at 2. But then after this value of x, we start to get negative area, and that negative area is subtracting from the area we've already accumulated, and these negative areas start to add up with our positive areas, and they're bringing the accumulated area down and down and down until we reach this point where there is as much negative area as there is positive area, and our accumulation is a net of 0. After this point, which is a little bit bigger than 6, we start to accumulate some more area, again positive, and that is why our accumulation function has a net area or a total signed area of 0.184. Okay, so this time instead of focusing on the picture, we'll back this up and we'll just focus on the numbers. So we're going to watch this number right here. Okay, so when a is equal to 0, we're accumulating area from 0 to 0, which is nothing. Okay, and we can see that the accumulation function is 1 minus cosine of x. So focus on this number here, the 0.64. That number should get bigger and bigger and bigger because we're accumulating more area until we reach a maximum of about 2, in which case after that point we start to accumulate negative areas. So we're getting negative 1.1, 0.98, 0.6, right, until we get to an area of 0. And then we pick up a little bit more positive area, so we're at 0.777. Okay. And all of that is about the accumulation function 1 minus cosine of x. And where does that come from? It comes from finding the antiderivative of sine. The antiderivative of sine is equal to cosine. The derivative of cosine is negative sine, so we need to put a minus sign on here. This is our antiderivative function. But then we need to evaluate from 0 to x, and so we will get negative cosine of x minus a negative cosine of 0. Cosine of 0 is equal to 1. Negative negative 1 makes a positive 1 minus cosine of x. So there is our accumulation function as shown over there. So if we want to know how much area was accumulated from 0 to pi, what was the definite integral from 0 to pi of sine of x dx? Okay, we'll do 1 minus cosine of pi Cosine of pi is -1. And there we can see that that is the largest value, according to the graph, of the area that we have accumulated. So this number, a little bit bigger than 3 right there, that maximum value occurs at pi. Okay? If you want to find the accumulation function of 2 pi, right, we will get 1 minus cosine of 2 pi. Cosine of 2 pi is 1. 1 minus 1 is equal to 0. And that is why when we get to a value of x is equal to 2 pi, we have accumulated 0 total area. There was a positive area of 2, and then from 0 to 2 pi, we must have picked up a negative area of 2, and those two areas cancel out and give 0. So one thing we can say is that the definite integral from 0 to 2 pi of the sine of x function is equal to 0. And that area split up into integral from 0 to pi of sine of x dx plus the definite integral from pi to 2 pi sine of x dx. Okay. Now we know that this definite integral comes out to be 0. Okay. The blue part, we've split this definite integral into two pieces. The first part from 0 to pi had a positive area of 2. So it had a signed area of positive 2. So a signed area is a sign, a plus or a minus, and then a number. Okay, so we're going to have a plus or a minus and a number. The other area, the pi to 2 pi, came out to be a negative 2. And it was the 2 plus the negative 2 that made that thing add up to 0 right here. Okay, so there is our accumulation function again, and its relation to the original function and the signed area of the original function. Okay, so we'll look at some more variety of examples in the next videos.